Hello geometry students! In this video we are going to learn about finding the interior and exterior angles of polygons. Okay, well before we start talking about interior and exterior angles of polygons, we should first find out what is a polygon. So a polygon is a closed plane figure with at least 3 sides that are segments. So it has to be closed, the sides have to touch each other. We're talking about 2-dimensional. And has to have at least 3 sides. They have to be segments. Some examples of polygons, you got your basic triangle, you got your quadrilaterals of all different kinds, your pentagon. Not great figures, but you get what I'm going for there. Non-examples, this is not a polygon. This is not a polygon. This is not a polygon. Now these, they don't have sides. This X, this angle right here, it does not have at least 3 sides. It's not closed. And this one over here has some rounded part. We need to have segments that are straight. Okay. So we're going to learn about a lot of different types of polygons. And for each of these, we're going to talk about how many sides they have, and then we're going to look at the pictures, and since we know information about triangles, we're going to try to break our figures into triangles. Okay, so the first one is a triangle. Okay, how many sides does it have? It has 3. Here's a picture of a triangle. Of course, they don't all look like this, but we know that a triangle has an interior sum of 180 degrees. So, 180 degrees. Now the exterior angle sum theorem, I'm just going to go ahead and give you this one, is 360 degrees. Okay, next, our quadrilateral. Quad means 4. So here's a basic square. You got all kinds of quadrilaterals, parallelogram, rectangle, rhombus, square, trapezoids, and all kinds of 4-sided figures. Can we split this up into different triangles? Yes. Well, if we go from one vertex corner to the others, my lines are not going to be so straight here, sorry about that guys, then we can split our quadrilateral, our 4-sided figure, into 2 triangles. Now we know that this triangle has 180 degrees and this triangle has 180 degrees, so we have a total of 360 degrees for our interior angles. And our exterior angles, I'm going to go ahead and give you this one, it's 360. For our next figure, a pentagon. Penta means 5, so this has 5 sides. So let's try to split up our pentagon into triangles, just going from one vertex point. We don't want to be drawing all the ones we can overlapping, we just want to go from one vertex point. So we can draw a line right here, and we can draw another diagonal right there, and then we end up with 1, 2, 3 triangles, where there's 180 degrees in each of those triangles, so this interior angle sum is 540 degrees. Our exterior angles, I'm going to go ahead and give you that. It's 360. Our next figure is a hexagon. Hex meaning 6 sides. Okay, so if we draw in our diagonals and draw some triangles, we've got one right here, and one right here, one right there. Again, my lines aren't great, but you can tell there's 4 triangles there. Each of those triangles has 180 degrees. So we've got 4 of them at 180 degrees. That's a total of 720 degrees for our interior angles. The exterior angles, I'll give that to you. It's 360. We'll talk about those a little bit more later. Next, we move on to a heptagon. Hepta has 7 sides, like this figure right here. So if we try to draw in our triangles, okay, I'm going to go from this one up here. I'm going to draw in a diagonal here and another one there. I can draw another one there. I can draw another one there. And even though my lines aren't perfectly straight, we can see that this makes 5 triangles. Each of those triangles is 180 degrees, so that gives us an interior sum of 900 degrees. And our exterior angles, I'm going to give you that, 360. Next we have our octagon. Octa meaning 8 sides, like your basic stop sign. Okay, drawing in some stuff right here. I'm going to draw in a diagonal right there. Hang on, I'm going to try to make that a little bit better. Got a diagonal there, and a diagonal there, and a diagonal there, diagonal there, diagonal there. 1, 2, 3, 4, 5, 6. This makes 6 triangles. Each of those triangles has 180 degrees, so that gives us 1080 degrees inside. And our exteriors, that's 360. Nonagon is our next one. Nona, 9 sides. Like this. Now, the more sides we go, the harder it gets to draw them. So I would not be very good at drawing this by hand. But when I try to draw in some diagonals, let's see here. I've got one there. I can draw in a bunch of diagonals from this vertex. And that gives us 1, 2, 3, 4, 5, 6, 7 triangles. Each of these triangles is 180 degrees. That gives us a total of 1,260 degrees. And our exterior angles, what did I give you that? 360. All right. For our next one, it is a decagon. Deca meaning 10. Okay, trying to draw in some diagonals here. Okay. Diagonal there and there. To that vertex. To that vertex, to that vertex, to that vertex, and to that vertex. Again, my lines are not so straight here, but you can try to draw your own if you'd like. Go for it. 1, 2, 3, 4, 5, 6, 7, 8. We get 8 triangles here. Each of those triangles is 180 degrees, so this is a sum of 1,440 degrees, and our exterior angles, I'm going to give that to you, it's 360. Okay, past that, we don't really have specific names for the figures. There are names, you could look them up, but beyond 10, after that, we call something an n-gon. How many sides does it have? N sides. So if we had something with 15 sides, we would call it a 15-gon. Something with 23 sides would be a 23-gon. Our pictures here, they're going to vary. And no, I'm not going to try to draw any of them. Based on patterns we've had from our previous examples, look at the number of sides and the number of triangles. I'm hoping that you're noticing a pattern right here. There's always, the number of triangles we can draw is always 2 less than the number of sides. So the number of triangles would be n minus 2. And since each of those triangles is 180 degrees, our interior angle sum is n minus 2 times 180 degrees. Because that's 180 degrees for each triangle. And the number of sides minus 2 is how many triangles. And our exterior angle sum theorem, that one, 360 degrees. That is a nice one to work with. Okay, so let's put this into play a little bit. Our interior angle sum, all right, the sum is n minus 2 times 180, where n is the number of sides in the polygon. So, what's the interior angle sum of a 13-gon? 13 would be our n, so our sum would be 13 minus 2 times 180. Go to your calculator or Desmos, type that in. 13 minus 2 is 11. 11 times 180 gives us 1,980. Or just type it in exactly it is right there. 13 minus 2 in parentheses times 180. You get 1,980. Let's take a look at another one. 5 of the angles of a hexagon are 122, 110, 95, 108, 135. What is the 6th angle? Well, we could figure out what's the sum of all 6 angles, and then we can just look at what we have for those 5. So our sum should be, since we have a hexagon here, and that's 6, 6 minus 2 times 180. Go to our calculator. That is 720. So all 6 angles have to add up to be 720 degrees. Well, we've got 122 for one of them. We've got 110 for another. We've got 95 for a third. We've got 108 for a fourth. We've got 135 for a fifth. And that 6th one we don't know. That's what we're trying to find. That's x. And it's going to total the sum right here, 720 degrees. And so you can use algebra or you can use Desmos. When you use algebra, you add up all these numbers. You're going to subtract that from both sides. Or if you go to Desmos, just type in your equation, and we're looking for where we see the vertical line if you're using Desmos, you're going to have to zoom out a bit because our answer right here is going to be 84 degrees. Our sixth angle is 84 degrees. Let's take a look at another one. Ooh, we've got a picture for this one. This is a quadrilateral. It has 4 sides, 4 angles. So we're going to do the same thing here that we did on this one up here. Let's find what the sum should be. The sum will be 4 minus 2 times 180. That's a total of 360 degrees. Any 4-sided figure always has a sum of 360 degrees for the angles. So our angles, we've got that x, we've got 88, we've got 106, and we've got 82. They all add up to 360. And so when we solve for x using algebra or Desmos, we will get that x equals 84 degrees. And I just realized that on my problem up here, I was looking at the wrong answer on my paper when I did that. I apologize. This is 84 is the wrong answer for up there. This should actually be x equals 150. My apologies on that one. I was looking at the answer for this one down here. Okay, now let's move on to the exterior angle sum. The exterior angle sum, I love this one. The sum of the exterior angles is 360 degrees. That's all. There's no formula. There's no adding, subtracting, dividing. The sum is always just 360 degrees. So what's the exterior angle sum of a 73 gon? Again, exterior sum is 360. What is the exterior angle sum of a 17 gon? It's 360. What is the sum of the exterior angles of the polygon pictured below? Well, these are all interior angles. We weren't asked about interior angles. We were asked about the sum of the exterior angles. It's 360. No matter what those interior angles are, the sum of the exterior angles is going to be 360 degrees. Now, I should mention that the exterior angles is defined as when you extend one side of the figure, and the sum of the exterior angles, that's 1 at each vertex. Okay. Now let's talk about something called a regular polygon. What is a regular polygon? It's a subset. It's a very specific, where it has all sides are congruent and all angles are congruent. So something like an equilateral triangle, where all of these sides are congruent and also all the angles are congruent. For a 4-sided figure, that would be a square. Not your basic rectangle, not your basic rhombus, because in each of those they might have one part, but the square is one that has all the sides congruent and all the angles congruent. So how do we find the measure of each interior angle here? Well, we take the interior angle sum and divide by the number of sides. So it's a total divided by the number of sides. I'll write that over here. Total divided by number of sides. And that total degrees, how do we find it? By n minus 2 times 180. So that would be our total, and we divide by the number of sides. How do we find the measure of each exterior angle? Once again, it's our total degrees divided by the number of sides. This one's easier, though, because our total angle sum is always going to be 360 for exterior. So 360 divided by the number of sides. Now, this will only work for regular polygons, okay, where all of the angles are equal. If we have angles of different sizes, then they're not all going to be the same, so we couldn't do this with them. Okay, let's do a couple more examples. What is the measure of an interior angle of a regular hexagon? Okay, make sure what we're being asked. An interior angle, and it's a hexagon. So hexagon, 6 sides. All right, an interior angle, let's find our sum. N minus 2 times 180. So I'll just write over here for hexagon, n equals 6. So 6 minus 2 times 180. So that sum is going to be 720. That's the sum of all of them. And we want one of those angles, so we'll divide by 6. And we'll find that one interior angle is 120 degrees on a regular hexagon. For the next one, what is the measure of an exterior angle of a regular hexagon? Once again, n equals 6. The sum of all of the exterior angles is 360. divide by 6 sides. That gives us 60 degrees for an exterior angle. Example 2. What's the measure of an interior angle of a regular nonagon? Okay. An interior angle and a regular nonagon. Nonagon. Okay, so 9 sides and equals 9. First, let's find the sum. The sum is 9 minus 2 times 180. So that sum, when we put it in our calculator, is going to be 1,260. Take that 1,260 divided by 9. That gives us 140 degrees for an interior angle of a regular nonagon. Second part, what's the measure of an exterior angle of a regular nonagon? Okay, once again, nonagon, 9 sides. The exterior angle, the sum is 360. Divide by the 9 sides, and we get 40 degrees. Now, something that's important to notice right here. 140 for an interior and 40 for an exterior. These two angles add up to be 180. On our previous problem for the hexagon, the interior angle of 120 and the exterior angle of 60, they add up to be 180. And that is always going to hold true because each interior-exterior angle pair are supplementary. Here's an interior and an exterior. Interior, exterior, interior, exterior, interior, exterior, interior, exterior, and they always make a linear pair. Okay, there's a few more examples. I'm going to actually put that one on a different video, so we'll get to that one in just a moment.